Hi, I'm Matthew Romoser, founder of System Scholar, though my students simply call me Doc Romo. My background is in Lean Six Sigma, human factors engineering, and work analysis, and I coach and mentor teams applying these principles in real operations. In this video, we're going to examine production time and how waste expands it. At the center of this discussion is something called minimum work content. By definition, minimum work content is the absolute least amount of value-added work required to deliver a product or service. And that is the goal. But in most systems, production time extends well beyond that minimum. So we'll define minimum work content more precisely, identify the contributors that increase cost and stretch timelines, and examine how excess inventory is often used as a crutch to mask instability instead of solving it. The objective is to help lean practitioners understand where waste hides within their processes and how it drives cost and production time. And with that, let's begin. When we look at a process from a distance, it often appears smooth. Materials flow from start to finish, people are working, product is moving, orders are shipping. But if we zoom in, inefficiencies and problems begin to reveal themselves. We see rework, we see excess movement, we see waiting, we see confusion. We see inventory piling up between steps. The interesting part is most of that waste isn't hidden. It's right out in the open. Over time, though, we normalize it. We say, that's just how it works here. We get so used to it that we begin to see it as part of the process. And because the system produces output, we may even defend it. It works. We're getting product out the door. Why change it? But working is not the same as working well. So the real question becomes, where does the cost actually come from in this process? And how much of it have we simply accepted as normal? To understand where cost comes from, we first have to define what should exist in the process. Minimum work content is the least amount of work required to deliver the product or service. These are the value-added steps. Each one transforms the product in a way the customer is willing to pay for. Remove one of these steps, and the product is incomplete. In a perfect system, production time would equal only this minimum work content. Start to finish would be nothing more than true value creation. But in reality, production time is almost always longer than this minimum. And that gap between minimum work and actual production time is where we begin our analysis. We're not searching for theoretical perfection. We are identifying non-value added time. Time that does not transform the product, time that adds cost without adding value. Some of it can be eliminated, some of it can only be reduced. But the objective is clear. Minimize non-value added time and move the system as close to true value creation as possible. The first non-value add that can sneak in is inefficient work design. In addition to minimum work content, this only serves to slow things down and increase production time. It's tricky because from the worker's point of view, they may feel productive when the work is poorly designed because they're moving constantly. They feel busy because in reality they are. But all that extra movement doesn't add any value at all. These include things such as unnecessary reaching, nonlinear layout, turning the body, searching, moving things around, amongst others. None of these transform the product in a way the customer is willing to pay for. So each one, by definition, is waste. Now, we've all heard of the 8 deadly wastes, which many of us have learned to remember using the mnemonic DOWNTIME. Defects, overproduction, waiting, non-utilized talent, transportation, inventory, motion, and extra processing. Now, you could argue that inefficient work design can contribute to all of them in some way, but in reality, it hits certain ones especially hard. For instance, waiting, when poor layout slows flow or parts aren't ready. Transportation, when materials travel further than they should. Motion, when unnecessary reaching, turning, or walking happens. And extra processing, when we handle or reposition things more than once. Inefficient work design doesn't just stretch time, it feeds directly into these wastes. The hidden problem that drives increases in cost and production time is poor training, miscommunication, and worker mismatch. When there are skill gaps, people work slower because they hesitate, they second guess, they make errors. And errors lead to rework and scrap. Poor communication creates delays and confusion. Work pauses while people have to then clarify what should have been clear in the first place. And when there's a mismatch between worker ability and task demand, production time expands. The product hasn't changed. The minimum work hasn't changed. But uncertainty and misalignment stretch the timeline. And that stretch is waste. Now let's connect this to the 8 deadly wastes. Poor training and skill gaps can lead to errors that result in defects and rework. Miscommunication creates waiting and confusion in the flow of product. Worker mismatch directly drives non-utilized talent, capability that exists but isn't effectively applied. And when people hesitate, double check, or have to redo their work, that becomes extra processing. Just like inefficient design, these issues don't change the product itself. They change the time, the effort, and the cost required to produce the product. And again, that added effort is waste. Our next problem is defects, which are often the most visible problem, as the impact of defects are often difficult to avoid. Defects increase production time by forcing inspection, rework, and correction. Sometimes the line stops. More often, the line continues to run, and the defects simply accumulate. And the people working within the system have to then circle back later to repair or redo what really should have been done right the first time. Either way, additional labor, additional handling, and often scrap or replacement material are introduced into the process. And that added time and added material cost is waste that could have been avoided if things were done right the first time. Defects generate rework and scrap. Every time something fails to meet requirements, additional labor and material are injected back into the process unnecessarily. Correcting those defects expands total processing time. Work that should have flowed forward now requires inspection, repair, replacement, or sorting. And defects rarely exist in isolation. Defects begin to trigger other forms of waste throughout your entire system. Obviously, defects themselves show up as rework and scrap, but they can also drive overproduction, as teams have then to build extra to buffer against failure. They also create waiting, as processes are idled, as problems need to be diagnosed and resolved. They increase transportation because defective material has to be moved for repair or containment. They inflate inventory as suspect or rework stock begins to accumulate. And they also increase motion through additional handling and inspection. Someone has to handle all of those defects. And they introduce extra processing because the job is effectively being done twice, and often followed by 100% inspection just to contain the defect and prevent it from moving on and reaching the customer. So defects don't just add cost, they multiply it. The next problem that increases cost and extends production time is poor management and inventory control. Inventory is nothing but cash sitting on the shelf. When we build to a forecast instead of real demand, push production creates stock that may or may not move. So just in case buffers, that extra inventory does feel safe, but that extra inventory hides the underlying problems in your system. And inventory is not free. Carrying costs include things like overhead. You have to have a building to store all of that. Storage, handling, damage, and shrinkage. Excess inventory increases exposure to demand volatility as well. When the market shifts, that stock becomes risk because you might be stuck with it. Inventory may look like an asset on paper, but in reality, inventory is a liability. If demand suddenly drops or a major customer finds another vendor, you can be left holding product you can't sell. So in practice, inventory is often just expensive insurance to hide an unstable or chaotic system. Now let's connect poor management and excess inventory to the 8 deadly wastes. When we produce more than demand requires, overproduction is the immediate result. That excess doesn't move, it just sits there and waits. Materials sit idle between steps, so your in-process inventory, and that ends up stretching your lead time. And as your inventory accumulates, transportation increases. Product is moved, stored, relocated, and then moved again. The inventory itself becomes waste when it exceeds what is actually needed to serve the customer. And all of that stock requires handling, more motion for counting, tracking, and managing that inventory. It also introduces extra processing in the form of storage, auditing, reconciliation, and control systems just to keep track of what you've built. And over time, defects can emerge as stored items degrade, they're damaged, somebody runs a forklift into them, they expire, or they become obsolete. So excess inventory may create a sense of security, but it does not stabilize the system. It only serves to multiply the waste within it. This is the goal: minimum work content, true value creation, and nothing more, nothing less. All of the other stuff, inefficient work design, poor training, and miscommunication, defects, poor management, and excess inventory, all of that stuff, it's important to note that these are not permanent features of your system. They're opportunities. Opportunities for improvement, opportunities for savings, opportunities to reduce time. And it's okay to say that your process has problems. Every process does. Waste, inefficiencies, friction, these are not signs of failure. They are simply signals. And they're also not about blame. They're not about pointing fingers at workers, managers, or departments. They're just indicators, evidence that the system can be strengthened. In fact, uncovering problems should be celebrated because once you're willing to acknowledge them, once you're humble enough to say, we can do better, now you have something you can improve. When we understand the problem, we can eliminate it. And as we remove these contributors, production time shrinks. We move closer and closer to minimum work content. That is where efficiency improves and your costs drop. And that is where people begin to feel the impact of meaningful improvement. There's a classic analogy in Lean that illustrates this perfectly. You've probably seen it before, but it's highly relevant here, and I'd like to discuss it. So as part of this analogy, think of the waste in your process as large, jagged rocks beneath the surface of a sea. Inefficient work design, poor training, miscommunication, defects, excess inventory, poor management, in-process inventory, they're all there. They're established and hard. They're jagged and sharp, and they're very disruptive, and they're real. Now imagine your production system as a boat, trying to navigate over these rocks, trying to avoid hitting them. Instead of putting in the work to grind the rocks down, many organizations choose instead to raise the water level. That's inventory. The water represents your just-in-case inventory. Forecast-driven push production, extra buffers, emergency inventory. And if you build and store enough inventory, well, yeah, the boat can float over the rocks, which feels safer. It feels easier. It reinforces the status quo, but that warm, fuzzy feeling you get with that buffer in place comes at a cost, and it is expensive. By building excess inventory to keep product flowing to your customers, you're merely covering up your problems and burning cash to do it. Reducing waste is challenging. It requires effort, commitment, leadership, and most of all, cultural change. You and your team have to grind those rocks down. And as you do, the water level can be dropped. You can reduce inventory. The system becomes more stable, and what you're left with is minimum work content. That is where pull systems live. That is where one-piece flow becomes possible. Kanban pulls product through your system, and you don't build anything until there's demand in the form of a placed order. You don't carry excess inventory. Implementing Lean and eliminating waste has many advantages. Carrying costs, rework, scrap, and excess handling are dramatically reduced. Quality improves because problems are addressed at the source rather than hidden. When cost drops without sacrificing value, your margin expands. Customers receive consistent quality and faster response times from you. And your people work in systems that make sense rather than constantly fighting instability. Employees become team members and problem solvers instead of workaround specialists. And with less inventory and fewer buffers, you can respond quickly to real demand. And finally, by removing waste, you free up time and resources without adding any headcount. So what does all of this really mean? It means most waste isn't random. It's embedded in how our systems are structured, how work is organized, and how decisions are made over time, and it becomes normal. Waste can be comfortable. It's easy to get used to. It's often excused as, that's the way we've always done it. If it's not broke, why fix it? And make no mistake, improving your processes is challenging work. It requires focus. It requires consistency. It requires leadership that is willing to look directly at the rocks instead of simply raising the water level to cover them up and hide them. But when you do that work, when you grind those rocks down, the payoff is real. Lower costs, better quality, stronger margins, more engaged people, and you have a system that actually flows. If you're looking at your own process a little differently after this video, I'd welcome the opportunity to have that conversation with you. Again, my name is Matthew Romoser, but most just call me Doc Romo. You can scan the QR code on the screen or use the link in the description to schedule a free 30-minute consultation with me. No pressure, just a relaxed discussion about your operation and where meaningful improvement might exist. At my core, I am a mentor and a coach, and I work alongside organizations to develop solutions tailored to their unique challenges. So thank you for being part of this discussion, and I hope to hear from you soon.